Welcome to The Explainer. Right now, I want you to imagine you're opening up a real Cambridge mathematics past paper. Let's say a classic 0580 or 9079 paper. The clock is ticking, the tension is building, you turn the page, and boom, there's a massive, complex mechanics question staring right back at you. Now, I typically see two types of students tackle this. First, there's Alex. Alex is brilliant but panics and overloads the paper with raw mathematics facts, just dumping every formula onto the page with absolutely zero analysis or structure. Then there's Sam. Sam rushes the process, completely misses the specific command word requirements, and scrambles to just find a final number. And what happens? You look at their papers side by side, and it's just a sea of red pen marks from the examiner. They both lost out on massive points. But today, we are going to fix that. We are going to transform you into a strategic symphony conductor of Cambridge mathematics. Specifically, we're mastering syllabus 9709, topic 4.4, Newton's laws of motion. We aren't just going to memorize formulas today. We are going to learn how to orchestrate your arguments so that each paragraph, each line of working is like an instrument in perfect harmony.
Okay, here's our quick agenda for today's masterclass. We're covering 1. The method mark strategy, 2. Fequalsma core principles, 3. The procedural framework, 4. Examiner warnings, and finally, 5. The visual story hack. Let's get right into it. Starting off with Section 1, the method mark strategy. This is the highest stakes reality of the entire syllabus.
Look at this quote from the senior examiners. It literally says, mastering F equals MA and weight equals MG is essential because it appears in every single examination series. You simply cannot escape this topic. It is the absolute heartbeat of the mechanics paper, the steady rhythm underlying the entire exam. Whether you're taking 0580, 0606, 4024, 4037, 4040, or moving up to 9709, understanding forces is a guaranteed feature. If you don't know how to conduct this specific section of the orchestra, your whole performance is going to fall apart. But here is the million-dollar question. If literally everyone studies F equals MA, and everyone knows for an absolute fact it's going to be on the test, why do so many candidates consistently crash and burn the moment the context of the question changes? Think about Alex and Sam. They practice a block on a flat surface 100 times, but the second the exam gives them a block on a 30-degree incline connected to a pulley system with friction, they completely freeze up. Why is it so incredibly hard to adapt?
The answer lies right here, the method mark strategy. The biggest secret to Cambridge mathematics is that examiners are not just looking for a magic number at the bottom of the page. They are actively hunting for the step-by-step orchestration of your working. Earning those top marks is about proving your systematic procedural process. It's about showing the examiner the exact logical journey you took, rather than just miraculously arriving at the destination. If Sam just scribbles down an answer without showing the command word requirements being fulfilled, those method marks are gone.
Let's move smoothly into Section 2, F equals MA core principles. This is where we lay down the theoretical architecture. Before we continue, subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so getting back to the core framework. Newton's laws demand absolute precision. The biggest conceptual hurdle, the thing you must separate in your mind right now, is cause versus effect. The cause consists of the actual forces applied to an object. We're talking friction pulling it back, tension in a string, the weight pushing down, the normal reaction force pushing up. Those are all active causes. The resulting effect is the mass times acceleration, the MA side of the equation. This is where Alex messes up. Alex just throws all the variables into a blender. But if you blur the causes and the effects together on your paper, your mathematical model crumbles. It's like a disjointed chord ruining a perfect harmony. You must explicitly model the sum of the causes on one side equals the effect on the other.
And here is another huge insight from the principal examiner reports. Cross-topic connections equal significantly higher marks. Examiners explicitly highlight that candidates who demonstrate connected, conceptual understanding are the ones getting the A-stars. This means you can't just isolate F equals MA. You have to be ready to seamlessly integrate it with kinematics equations, with work, energy, and power. You're bringing all the different instruments of the Cambridge syllabus together into one cohesive performance.
So, we know the theory. Now, let's jump to Section 3, the procedural framework. How do we actually do this on paper when the timer starts?
We call this the mathematics success blueprint. It is an exact 5-step standardized sequence you absolutely must follow to tackle any 4.4 examination question. Step 1, deconstruct the question. What is the actual command word? Is it calculate, show that, determine? Step 2,
Extract the data. Pull out the mass, the angles, the coefficients. Step 3. Select your framework. Are we resolving vertically, horizontally, or parallel to an inclined plane? Step 4. Execute your notation cleanly. And Step 5. Present the information following strict conventions. If you watch a top student rewrite a failing answer, this is exactly what they are doing. They're transforming chaos into a structured, logical flow.
But to hit those elite tier marks, top-scoring candidates apply a higher-order loop. They deconstruct, they solve, and critically, they evaluate. Now think about the Peel framework: point, evidence, explanation, link. While usually used in English, it brilliantly applies to the evaluation stage of extended mathematics responses. You make your mathematical point, you provide your evidence through calculations, you explain your algebraic steps, and you link it back to the original physical scenario or command word. It's a continuous loop of checking if your answer actually makes sense in the real world. Mid-roll. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, welcome back. We are now in Section 4, Critical Examiner Warnings. This is where we run our interactive workshop.
We went deep into the principal examiner reports and identified the top 3 specific, repeated failures that consistently cost candidates marks year after year. Let's treat this like a data scan challenge. I want you to imagine a complex mathematics chart right in front of you. You have 60 seconds to scan the data. What is the core trend of why students fail? Let's break down the 3 mistakes.
Mistake number 1 is candidates completely confusing cause and effect. Think back to our Find the Flaw challenge. If I show you a flawed sample mathematics paragraph, the sentence losing marks is almost always the one where a student puts acceleration on the wrong side of the equation or treats MA as an actual physical force acting on the body. Examiners hate this. It shows a fundamental lack of understanding of Newton's second law, and it completely derails your mathematical model from step 1.
Mistake number 2 is formatting negligence. This goes back to our friend Sam rushing through the paper. Students simply forget to check their presentation. They use incorrect terminology, they forget arrows on their force diagrams, they use lowercase m when the question specified uppercase M. It sounds nitpicky, right? But remember, your examiner is trying to follow your orchestration. If your sheet music is an absolute mess and you haven't laid out your equations clearly, they cannot award you the method marks, even if your final numerical answer somehow happens to be right.
And mistake number 3, generic responses. Examiners specifically note that when a question provides a highly specific physical context, like 2 particles connected by a light, inextensible string passing over a smooth pulley, students will just write down generic, rote-memorized textbook equations that do not match the actual scenario. You have to orchestrate your answer to the specific tune of the question being asked.
To avoid these traps, we need to do a 30-second speed writing mental check. Examiners have issued an explicit alert. Always define key terminology before using them in extended responses. If you introduce a variable like T1 or FR for friction, state what it is. Formulate your perfect Peel paragraph. Make your point, define your terms, show the evidence, and link it all together logically. Do not make the examiner guess what your variables mean.
Let's move to our final section, Section 5, the visual story hack. This is the final system to lock all this in. To successfully retain F equals MA and weight equals mg and actually apply them under pressure, use a visual story method. Draw a large, clear diagram for every single mechanics question. Encode the abstract numbers into a physical, visual story. Draw the arrows, label the forces, visualize the direction of acceleration. When you physically map out the scenario on the page, your brain naturally sorts the causes from the effects. You stop memorizing blindly and start genuinely understanding the physics of the system.
So here is your cheat sheet recap, the 3 rules that guarantee top marks. First, command word decoding. Apply the correct formats the question asks for. Second, Peel framework application. Use appropriate terminology and structure your reasoning clearly. Third, time management matrix. Always leave time to evaluate your performance and do a reasonableness check on your final numbers. Final CTA. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, @Ace the Exams IGCSE, to excel in your Cambridge examinations. Subscribe right now to Ace the Exams IGCSE and clip that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the exams. Your Cambridge success starts here.
And that brings us to the end. I want to leave you with one final, provocative question. Are you ready to stop just doing math and start orchestrating your next past paper using the method mark strategy? Take these systematic steps we learned today, apply them to the hardest, most unfamiliar F=ma problem you can find, and watch your grade potential absolutely skyrocket. You've got this. Happy studying, and I will see you in the next explainer.